complicated examples. Like here, 5x to the fourth. I take 4 times 5 is 20. X, lower the power by 1. Minus 2 times 2 is 4 times x, lower the power by 1. Watch this x to the first. Now 6, where does the 6 go? Well, technically, remember the derivative of a constant is 0. We said that earlier. But also you can think about 6 as being 6 times x to the 0 power. It's actually a power function in disguise. So if you use the same rule, it's 0 times 6, lower the power by 1, and you still get 0. Okay? Now it works with negative exponents just as well as positive exponents. But the only thing is that when you subtract from the exponent, it makes it further away from 0. So it's negative 3 times 1, because that's the coefficient, times x, lower the power by 1, because negative 3 minus 1 is negative 4. Okay? So hopefully you got that on your own. But let's summarize this rule for doing derivatives. It's called the power rule. Yes, I'm using a different smartboard, so it's not perfect, but the penmanship is better. So I'm writing like a 6th grader instead of a 3rd grader today. So the power rule goes like this. If you take a power function, a times x to the n. Actually, I want to take the derivative of it. Sorry. The derivative of the function a times x to the n. I wonder if you can write a general rule for this. Using the same pattern, exponent times coefficient, so it is a times n times x, lower the power by 1, which in general we would say is n minus 1. Okay? So congratulations, you've learned your first derivative shortcut rule. So whenever you have a power function or a sum or difference of power functions, aka a polynomial, you can use the power rule instead of the limit definition to find the derivative. Okay? Alright, so another property that kind of is implied in the work that I'm doing here is another one that you might be asked explicit information about. I made it sound dirty, but I just mean you'll be asked specifically about this particular rule. It's called the sum or difference property. And the sum of difference property says that if you take the derivative of one function plus another function, then that's always going to be equal to the derivative of the first function plus the derivative of the second function. Okay? So essentially you're just doing the derivative of each piece of a sum. And it works with differences as well, so I'll put a plus or minus in the formula. Okay? Alright, so let's do some examples. First one. Let's say we're given a function, 4x to the fifth minus 2x squared plus x minus 8. That's a squared. And we're asked to find f prime of 1. Okay? Now, a couple classes ago, we would actually set up the limit definition, replacing a with 1, work out the limit to find the slope or the instantaneous rate of change. What we're going to do now is use the shortcut rule. Okay? So what I'm going to do is go back to this and use the power rule to do the derivative. Okay? So the power rule, the derivative of 4x to the fifth, what would that be? 20x to the fourth. Minus, derivative of that term, 4x, plus the derivative of x. Well, that's kind of a tricky one. It's x to the first coefficient of 1. So the derivative of x is just going to be, if we think about that, it's going to be 1 times x, lower the power by 1 to 0, and x to the 0 is 1, so the derivative is just 1. You could also just think about the last two terms. X minus 8 is linear, and the slope is the number in front of x, which is 1, so we just get plus 1. The derivative of the constant is 0. Okay? So that is our general derivative. Now if I want to find f prime of 1, you just substitute a 1 for x. So it's 20 times 1 to the 4th minus 4 times 1 plus 1. And just work out the answer to that. Turns out that's 17. Okay, so there's your derivative. Okay? A little bit easier than doing the limit definition, although if you prefer to use the limit definition, you can do that at any time. Sometimes I like to do it just for fun, because it is fun and rewarding to think about it. But not necessary from now on, unless you're specifically asked to do it. Okay? So, same process, takes about, 1/4 of the time as the other definition. Okay? Let's do another example. So you have the function 3 over x to the 4th, and you're asked to just find f of x. F prime of x, rather. So sometimes you're going to be asked to find the specific derivative at a specific point, and sometimes you're just going to be asked to find the general derivative formula. So in this case, we're finding the general derivative formula. Now fractions are particularly difficult with the limit definition, because you have to do all the common denominator stuff and fractions within fractions, and it's kind of a nightmare. But with the power rule, it makes this problem a lot easier. The first thing you want to do is rewrite this as a power function. And you got to remember that when you have x's in the denominator, you can rewrite them with negative exponents. So this is the same as 3 times x to the negative 4. Okay? So once you write it as a power function, now the derivative is easy. You just use the power rule. So the derivative, negative 4 times 3, negative 12 times x, lower the power by 1, be negative 5. And usually you want to write your answer back in the same form as you're given the problem. So I would change this back to fraction form. So I put negative 12 over x to the 5th. And that would be your derivative function. Okay. All right, so for simple examples like these, it really is that easy. Find the derivative using the power rule, substitute the number if that's appropriate, and go from there. Okay, so let's do an example of a little bit harder one. And I'll do one, and then I'll give you guys a chance to do one before we move on. Let's say we're given that the function is x squared plus 3x times 2x minus 1. And we're asked to find f prime of negative 2. Okay. Now, although we talked earlier about there being a sum or difference property, there actually is no power. There's no product property. So you can't just take the derivative of this and the derivative of this and multiply them. Okay? I'll convince you of that in a bit. So at this point, the easiest way to do this is to multiply it out. So you got a binomial times a binomial, so you can just FOIL this out before you use the power rule. So I'll change the form and simplify the problem. So first terms multiplied together, this one times this one, it would be 2x cubed. If you do the outside, you get minus x squared. If you do the inside, it's 6x squared. And if we do the last, it's minus 3x. Okay? Combine like terms, we get 2x cubed plus 5x squared minus 3x.